Welcome back, everybody. We're going to continue the discussion about organizing data. And next, we're going to talk about box plots. Box plots, often called box and whisker plots, have quite a bit of detail to them that we're going to explore in this section. All right. Now, the reason to use a box plot would be that when a data set contains a smaller number of values, a box plot is a good way to graphically represent the data set. So when you have a smaller number of values, a box plot might be a good way to show your data on a graph. All right, the first thing we're going to do is we need to begin with the 5-number summary. Now, we ended the last section by briefly talking about the 5-number summary, but let's go over the elements of it again. So the first is we have the minimum value. The second is the first quartile, or 25th percentile. Oh, that should be a 3. The median, or 50th percentile. Q3, or the 70, oh, that's a terrible R. Or the 75th percentile. And the 5th is the maximum. All 5 of these numbers are going to be essential elements of your box plot. All right, so let's just jump right into an example. I think it's probably the best way to show you how to construct it is to use some real data. All right. So a stockbroker recorded the number of clients she saw in each day over an 11-day period. The data is shown below. Construct a box plot for the data. All right, and there you have a list of what should be 11 numbers. So I'm going to scroll up. I'll keep the data here. That way we can refer to it. My first step is going to be arrange the data in order. All right, our goal is to get this 5-number summary. All right. And the best way to get the 5-number summary is to start by arranging the data in order, because 2 of the 5 numbers become fairly obvious, meaning the minimum and the maximum. All right, so why don't you pause the video, take a moment to arrange the data in order, and we'll talk more when you come back. All right, so I got 23, 27, 29, 30, 31, 33, 38, 40, 42, 43, and 51. All right, so again, there's the minimum. Here's the max. Another benefit of having the data arranged in order is another number in your 5-number summary becomes very easy to calculate, which is the median. All right, so we have 11 numbers here. So why don't you pause the video once again, find the middle number, and we'll check our answer on the back end. All right, so I go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's your median. Is 33. Yeah. All right, that was a good idea. That went wrong. Median. All right. So now we need to talk about the next piece. All right, the next piece is Q1. So the median has already been used. All right. So now we look to that part of our data set, and I want to know what the middle number is. All right. And the middle number is 29 over here. Oop. All right. And now we're going to look on this side for our Q3 because I want to find the middle number here. And there is Q3. All right. So we've just found all 5 numbers. I have the minimum, Q1, the median, Q3, and your maximum. All right. So the next step is we draw a scale. I'm going to scroll up. We can always scroll back, but all right. So I'm going to do my scale. I'm going to go 20 down here. It's a little lower than I need to. 50 here. I know our maximum is going to go to 51. It can go a little bit beyond. All right, and our minimum is 23. So I'm going to label this, literally label it 23. All right, and we're going to go all the way up to, let's take a look. Our Q1 is 29. So I'm going to go a little bit before 30. I'm going to go straight line as best as I can. Call that 29. Going a little bit beyond because when I look back, my Q3 is 42. Doesn't have to be perfectly to scale, just a little bit over 40. That way I know that you know it's 42. And then I'm going to stretch all the way out a little bit past 50. And that should be 51. I'm going to make that a little smaller so I can make a better 51. All right, now the last number we need is our median. Our median is 33. What we do is about halfway, a little bit more. And we put a 33 right there. All right, so other than my poor drawing aside, this is basically a box plot. Now, to make it perfect, if we're going up by 5, we really should have a 45 there. All right, so some things that you can tell just from a box plot. If the median is near the center, all right, then the distribution is going to be symmetric. Now, this median, kind of close to the center, but it's not in the center. If the median falls to the left, as it does in this case, our distribution is called positively skewed. If the median falls to the right, our distribution would then be negatively skewed. All right. Now let's talk about our whiskers. All right. So let me change the color here real quick. Our whiskers are these parts here, kind of like cat's whiskers. All right. If those two whiskers are about the same length, then our distribution would be symmetric, right? If the right line is larger, our distribution is positively skewed. If the left line is larger, our distribution would be negatively skewed. All right, so there is a lot of information you can get from a box plot. All right, the key is it needs to be drawn, I would not say perfect, but relatively accurately. All right, so let's take a look at another example. Using box plots, compare the two distributions of sodium contents of a sample of real cheese and a cheese substitute. All right, now it's one thing to know how to make a box plot, but in this problem, we're also talking about how to use them. by displaying your data graphically, you can learn a lot from this data. So let's try to make 2 box plots on the same scale, and let's see if we can draw any conclusions. All right, so I'm going to scroll up because I need the space. But the first thing I need is I need my 5-number summary for real cheese. All right, so why don't you at this point pause the video and do the work to find the 5-number summary, meaning the min Q1, the median Q3, and the maximum for real cheese. All right, so hopefully you pause the video. I'm going to write out the numbers in order. You've already done the work, so I'm only hoping that your answers will match mine. $180, $220, $240, $310, and $420. Now, if I'm going to count these real quick, I got 1, 2, 3, 4, 5, 6, 7, 8. All right, I think this may be the first time that I have an even amount of data in my set. So I'm going to count in from both sides. I'm going to use my highlighter so I don't destroy my data values, and do my crossouts just like I would any other time. However, I wind up with 2 values in the middle. All right. And I did mention before that when you have 2 values in the middle, you're going to add them up and divide by 2. So if we add them up and divide by 2, we wind up with a median of 200. All right, now I'm going to go, all right, now I can use this value because it's not actually the median. And I want to find my Q1. And I notice that I have 2 values in the middle. I'm going to add them up, divide by 2. So my Q1 is going to equal 67.5. And I'm going to do the same thing for my Q3. I have 2 values in the middle. Add them up, divide by 2. My Q3 equals 275. And again, the min and the max are obvious, 40 and 420. All right, so now I'm going to ask you to do the same thing with the cheese substitute data. So pause the video. Let's do that work, and we'll talk about the answer on the back end. All right, again, hopefully you put in the work. I found the median to be between 260 and 270. So that's 265. My Q1 equals 215. My Q3, I believe, was 300. And again, the min and the max, 130 and 340. All right, so if you had any trouble with the last set, hopefully you fixed that with this set. And now we can be ready to make our box plots. All right, so I need a scale that's going to suffice for both numbers. So I'm going to scroll up. I can always scroll back if I need the numbers again. I'm going to make my scale down here. So I have a lot of room. All right, and I'm going to go 0 to, let's go up a little bit. $500. And I'm going to make 100, 200, 300, 400. And again, we're going to estimate where these things are going to fall. I am going to put real cheese on top. So I'm going to start, I'm going to I'm going to change colors just so you see the contrast, all right? So I'm going to start at 40, which will be about there. That's my minimum. I'm going to go to 67.5. And then I'm going to create my median is 200, all right? Looks like it falls right at about 200 to me. Seems okay. And my box extends all the way to 275. And then my whisker goes all the way out to 420. A little more than 400. 420. And again, I'm trying to make this as good as I can. I'm going to put real up here. All right, now I'm going to switch colors. I'll switch to purple. Purple's a nice color that shows up. And we're going to start with the cheese substitute. So I'm going to put substitute. And we're going to start at 130, which would be about here. And then we're going to go to where? Where's my Q1? Q1's 215, all right? So we're going to go to 215, which is just a little bit more than 200. All right, and now we're going to go all the way to 265. So we don't have a long way to go, but just a little bit more than half. There we go, 265. And then my Q3 is 300. So again, not that much further to go. And then I'm going to extend all the way a little less than half at 340. All right. So we're taking a look at these two box plots. And the thing that I see is that the cheese substitute is a higher median. Pretty obvious from the numbers, but it kind of drives it home with the graph. And I could also see that the real cheese has a higher variation. Now, I did not calculate variation, and it's not so quick to calculate variation. All right? To say real cheese has a higher variation is proven by the graph. If you notice, the spread of data for real cheese is indeed more than the spread of the data for the cheese substitute. All right. So now I want to look a little bit more at our measures of position, because we've done some percentiles, but we've done the percentiles that were pretty easy. We had 50, 25, 75. So I want to talk a little bit about something called the interquartile range. Now remember, our quartiles that we had were Q1 and Q3, right? So our interquartile range is Q3 minus Q1. And you might ask, when do we use this? And that would be a perfectly valid question. When we're measuring something called an outlier. Okay, now an outlier is an extremely high or extremely low value in the data set. All right, now there are a lot of ways to check for outliers, but one of the ways we have uses the interquartile range. What we do is we say, if we take Q1 and we subtract 1.5 times the IQR, interquartile range, and we take Q3 and we add 1.5 times the IQR, interquartile range, what we say is any value greater than that or less than that are going to be outliers. All right, so let's do a quick example where we check for outliers. All right, so we're going to check for outliers. I'm going to give you a data set. The data set is 5, 6, 12, 13, 15, 18, 22, and 50. All right, so let's start this by calculating what Q1 and Q3 are. So why don't you take a moment, and guys, since you're experts at this now, why don't you do that? All right, so pause the video, find Q1, Q3, and we'll talk about our answers on the back end. All right, so Q1 I got to be 9. Uh-oh. And I got Q3 to equal 20. So if I do 9 minus 1.5 times the IQR, which 20 minus 9 is 11, I get negative 7.5. You can check my work, but I think I'm pretty good with that. And I say 20 plus 1.5 times 11, I get 36.5. So basically, when I'm looking to identify outliers for this particular problem, I'm looking for any value below negative 7.5 or higher than 36.5. I have one value that fits that definition. That is 50. So 50 is the outlier. There are other ways to check for outliers. This is just one particular way. All right. So last thing I want to do is I want to talk a little bit about how to find percentiles that aren't necessarily the quartiles, the Q1, the Q3, the Q2. All right. So let's try this example. A teacher gives a 20-point test to 10 students. The scores, I'll write the scores out in just a minute. Find the percentile rank for a score of 12. All right, so I have my data for the example is going to be 18, 15, 12, 6, 8, 2. Ooh, person did not do well on this test. 3. Ooh, 5. Ooh. 20. All right. And 10. All right. So what basically we're looking for is we're looking for this guy who scored a 12. What was his percentile? How many people scored? How many people did he score better than? All right. So the first thing I want to do is I want to put this data in order. All right. So we'll start with 1. Oh, that looks like a D. I just want to do a 1. Let's put the data in order. All right, and so we put the data in. I got 2, 3, 5, 6, 8, 10, 12, 15, 18, 20. Believe I got them all in order. Now, the second thing I need to do is I need my formula. So my formula is percentile, excuse me, I can spell, percentile equals the number of values below your target plus 0.5 divided by the total values. And we'll times it by 100 to get the actual percentile. This will give us a decimal. All right. So the reason I needed these in order is I need to know how many values are below 12. So I got 1, 2, 3, 4, 5, 6. So I got 6 values below 12. So now I'm going to calculate. I got 6 plus 0.5. And I do believe I said there were 10 students. Looks like 4, so 10 times 100. All right, at this point, why don't you guys pause the video, do the calculation, and we'll see if we get a good answer on the back end. All right, so hopefully you did the calculation. I got 65th percentile. All right, and basically what that means is the student who scored a 12 on the test did better than 65% of the class. All right, so that's what I got for this section. Thank you for listening. There's a lot more practice, and I'll see you guys soon. All right.